Hello guys, welcome to my channel Techmon.in. Today I'll be sharing another exciting tip and trick with you, and that is not all. I'll also be sharing some in-depth intuition behind why or how Midjourney or Stable Diffusion or any other AI model might be generating these results. So stay tuned. So first, the tip or the keyword we are going to understand or elaborate or experiment with is ToTooDo. You might be wondering why I picked this up. It's just random. There's no logic behind it. So now let me just turn on my fast mode so we can get the results faster. Already you can see I tried this keyword here, but let me run it right in front of you guys. So let's see what it generates. So I'll be definitely creating some separate video on byte pair encoding, but today I'll be showing you what byte pair encoding, high level, what it does and how it might be affecting our results. So so byte pair encoding is the first step in which the text we pass to any AI like Midjourney or Stable Diffusion, they are broken down into subwords or small tokens. So byte pair encoding is one such technique which tokenizes the input text or sentence. So to understand this keyword here more better, why certain results might be generating, I'll be breaking down or tokenizing my this command here to do into subwords and check how these subwords might be impacting our results. But before that, to tokenize our text, I'll be using this brilliant and amazing project, byte pair encoding MB project, which has subword embedding. They have already trained the subword embeddings in 275 languages, and they have trained it on Wikipedia data. So I'll be using, they have already given how we can install the package and how we can simply use this. So I've already installed this package on my local Python environment, and here as you can see, I first imported the package, then I set language as English, and it automatically downloaded all the required model. It has trained under the hood, and now after that I'm just encoding, so I'm not getting the embeddings directly here. I'm just seeing how byte pair encoding generally tokenizes our word. So we'll come back to it. Before that, let's see what it generated. So as you can see here on the top left chart, or top left this image, we can see a image of a girl, and there are some eels like creatures, sea creatures, and you can see how it is like they are part of her or coming out of her or taking over her, something like that. And here as you can see, there are some feather kind of pattern also, maybe that's how the dress of this girl is. And here you can see there is some text, right? And when we look at this top right image, we can clearly see image of a boy. There is a bird here, and there is a bird on the back of a boy, and there is also some text written here which is R triple O. And as you can see, the boy's face look little scars or blood or something, like it might something hit on boy's face, and boy is like bleeding, something like that. And right below that we see something technical kind of kid here. It looks much younger, and you can again see the names, like this letters are coming on the boy's this jacket or something, and also on the oxygen kind of cylinder or something the kid is carrying. And there are some goggles, like boy is wearing some goggles here. So amazing results with such simple prompt. And here also you can see image of a girl. Again, the text is appearing all of this images, and she is holding teddy bear, a cute teddy bear in one arm, and some jam or some chocolate on the other hand. So amazing results. I'll be regenerating it just to see how it works. And also I'll be generating uh, using this text multiple time to see how it might impact our results. So meanwhile it is generating. So first step, so basically we generally pass just the prompt to our Midjourney or Stable Diffusion algorithms, right? So first step which goes under the hood is tokenization of text. So as you can see here, it has already been tokenized. Okay, something here. So let me just. So I'll be taking a pause here. Meanwhile, I'll fix this. So now coming back to this again. So as you can see, when I encoded the text, basically it parsed it and it tokenized it. And as you can see, it has broken down this text into small chunks. Before we come to that, let's say we tried today is a great day. So as you can see, it has actually each word has been tokenized as one. Um, this is something I was not expecting. Could it be due to above word is out of vocabulary? Let's see. So as you can see, most these are like maybe ideally what so how I can explain this is, as you can see, these are like today is a great day. These are in a complete word in themselves, and also they are like they're in their root form, right? So, but there is a word like exciting. Its root form is expect. So here, as you can see, it broke down this expecting into expect and ing. And also, I think could it be due to I think rest words out of vocabulary, right? So in its vocabulary, it might not have found this directly, or due to the frequency, it broke down this into O and OV. So how byte pair encoding works is it starts with single characters, okay, and then it starts to merge two characters together, and the two characters having the highest frequency get merged together and rest on, and then it keeps on repeating the pattern. Basically at each step it will merge two characters and then add more character, third character to it, and then fourth character to it, until we have run out of number of iterations we passed, or the vocabulary. We can control these. Okay, so now as you can see here, it broke down into tot, OOD, and O. And now we are going to see how so basically now what happened, this word ToTooDo has been split into three, one, two, three. So now once we have tokenized the word, these tokens will be passed as input to the model. So model has like this model under the hood has uh, basically clip algorithm, where it uses these tokens to basically get their embedding, their respective embedding. So tot will have its own embedding vector, OOD will have some embedding, and O will have some embedding. So not going into too technical, basically each word will have some numerical value assigned to it, and finally these numerical values against each of these subwords or tokens went further into the algorithm to finally generate the image. Okay, so that is high level step. So now as you can see, coming back to this, as you can see again, we have seen got some brilliant results, right? These are pretty amazing results. Like here you can see an owl, like beautiful blue Persian color, and such beautiful eyes, like totally, and the desert in the background. Here, this froggy, right? This is amazing. I'm going to upscale this one definitely for, but later. As you can see, it is like has a smirk on his face. I don't know what it is looking at, but definitely this is amazing. And this is certainly like snail-like these antennas and owl-like body and eyes also like owl, but it is not owl overall, right? And this is just some beautiful image of a girl, and here you can see some text appearing, right? So now we are going to see how the algorithm might be making decisions under the hood. So first, I'm going to use another tool, which is by ROM 1504 at GitHub. It is hosted on GitHub. So basically, what they did is they used the clip model, trained clip model, and now clip has two parts. It has images and it has text. So now what they did is based on the image and text. So for example, this is the text I passed here. It brought top images which are highly correlated or highly has the basically cosine similarity, uh, uh, lowest cosine distance or highest cosine similarity with this text word. So these are the top images which were found in the clip database, which was used for training the clip embeddings. So to train the clip model, we need two pieces. One is image and their corresponding captions or text, right? So that's how it works under the hood. I'll be sharing definitely in detailed videos about byte pair encoding, clip, and then finally the stable diffusion algorithm. But for now, what we are doing is we are passing a keyword here, and from the clip it is finding the basically embedding vector for both all the images and for the past word here, and then it checks the cosine similarity between the sentence, the past sentence, and the images, and returns the images which has the highest similarity. So these are some of the top results. So as you can see here, this owl like shape is appearing, owl like some creature or some bird is appearing, and in its text, as you can see, something TOO is written, and there are a lot of text based images are there, like you can see some text is written, and all of these contains either DO, TO, or TOO, something like that, right? So these are the images, and you can see here is monkey, there is crocodile, then there are some girls images as well, and there are, as you can see, boy mm, holding a alto sign. Like there are a bunch of different, but we can definitely see a lot of, and here you can see a bird as well, right? Parakeet, and there are like text, lot of text are appearing with these images, right? So definitely here also in the results we saw text are appearing across all the images, right? Here text is there, and above also we saw a lot of text appearing. It could be possible that in their training data, Midjourney has certain such images which contain text like this, right? So, and there are so many images with text, right? So internally, model has learned whatever is present on the whatever text we pass, it has to be present in the image as well. For example, this is the best example, right? You can see here caption or image uh, text has TOTO, and it is also on the image, right? So due to these such data points, algorithm learned to just mimic this behavior. Whatever text we pass, it tried to put that text on the image itself. Like here also you can see Toby is written, Topito is written, and it is also Topito is also on the image. So this is how, this is why and how whatever we write, you might have observed when you are writing some prompts, or when you are trying to create your art as well, whatever you write, sometimes they appear on the images as well, right? Like here we are seeing. So it is because Midjourney has, or any algorithm like stable diffusion has such in their data set. Now this is about the total word ToTooDo. So I also next tried passing these three subwords separately into same tool just to see what results we get. So when I pass the first subword tot, I get these, like there is a dog here, there are tater tots, one of the North American dish. Basically, if you are not aware of that, so what they do is grate the potatoes and then deep fry it. So this is the dish they are showing here. But definitely there are a lot of cute puppies and dogs, and here you can see like a cartoony style tater tot. And when we go below, there are like man face and lot of text. Here also you can clearly see lot of text is appearing, and here are some dolls, animated cartoon scenes, again doll or toy. And here you can see one of the anime character from Hero Academia. This is Shoto or Todoraki. And then you can see like a lot of like different puppies are there. Yoda is here, and anime characters are there here. So these are definitely not all the images which are there present in the dataset, but these are some of them, right? And you can see kids, boy, such like we also see here, right? Kids like and boys are appearing, like these childs are appearing, this kid is appearing, right? And all of these faces by default are like childish, like children faces, not adult or anything, most of them. So it could be due to the data is available such as you can see here, right? Lot of different puppies and everything. So as you can see, there is a wide variety of images present with tot. And these like toys, again toys, fluffy toys, we have such wide variety which might be getting reflected in our results as well. So this explains some of the reasons toys, soft toys are appearing. This can explain why we have certain characters, like maybe this character here. We're having some toy at the back, and this kid is also holding a teddy bear and so on. Now I also passed like OOD, which is a second sub word present or tokenized from our input. So here you can see like this octopus faced man. So I wasn't aware which character is that. I researched it. It is from British TV series, goes by the name Doctor Who, and definitely it has a very high IMD rating. So definitely if I get time, I'll definitely watch it. And if you like, you can also watch and share your experiences with me. But again, here a lot of no denying white text might be appearing. We have a lot of text, but again we have like toy here with big eyes, and even ood, right? Oh, it does not has big round eyes, but definitely some weird tentacles or something, right? And here as you can see, we saw something over the girl's face here, right? Some sea creature like things taking over. So it could be due to these kind of images present. This is another one of the character, goes by the name Ood from Doctor Who series. And here you can see the cartoony styles, big eyes are also appearing associated with this character. So there are, as you can see, a lot of variety of images, and mostly from this. And you can see big eyes and round and cartoony shapes are there. So which might be again influencing our results. By what degree we can't tell. Stable diffusion is still trained on public data sets, so chances we might be getting such results directly reflected there, the chances are very high. But Midjourney, because we are generating arts on daily level, and we are upvoting certain arts which we really like, so Midjourney might be using such data as well for their training. So the data quality of Midjourney might be really, has might have enhanced over the time. And that's why here we definitely some of the patterns here, like death, appearance of text and similar patterns, like childish faces is appearing and so on. But overall the quality of the images generated better. So it could be just due to that. So now checking the last subword, which was letter O. And previously also we have seen letter O has wide variety of basically output and some amazing and brilliant, really good output. But here, when I pass this O, I'm getting most logos kind of things. As you can see, uh, logos are appearing with letter O, shape of O's, something like that. And these again might be influencing somehow. Like here, you can see eyes are also appearing, these round. And here, earlier also, if you have watched my previous videos as well, with letter O, we generally get round images like round eyes, round certain all the objects like glasses and all, which are more round in shape. Like here also, as you can see, these round lenses or something, right? So definitely it could be due to influence of these, as we can see wide variety of O or circular shapes are appearing, and these might be influencing the results. But again, these might be more prominent or clearly visible on stable diffusion, which is again trained on more public data sets, which might be containing such images. But this may not be there for Midjourney, because over the time they might have or they might have spent more time cleaning the data, or might have spent more time into refining basically their data set. And also, as I mentioned, they might be using, or they, I think they definitely are using the artwork we are generating, and we are upvoting. So when we upvote or upscale, there is a signal we are giving that these look something like directionally they look promising or good results, right? So Midjourney can always use such results to improve, or use this as training data to improve their algorithm. So definitely Midjourney result, when we do similar exercise with Midjourney data, we might get something different, but definitely it is proprietary to them, and we won't find such data sets publicly available. So now coming back to this, this might have provided you, given you more intuition how any text to image AI algorithm might be working under the hood. Now coming back to this result, earlier we were trying single keyword, we were getting such results. When I just replicated them more time, as you can see now, this is again tortoise, and here you can see it is like high tech tortoise, maybe ready for war or something. These look promising. Like always, I'll be increasing the frequency of these, and we'll see how uh, it impacts the output. Also, I'll be passing this to byte pair encoding algorithm as well, just to see if it generates some different subwords. But ideally, it should not, but let's do, because here we are not training these subwords, we are just using them. So whatever it did while training, it will just reflect. Those things will get reflected. So during this training of these subwords or byte pair encoding, they have learned internally like this text will be splitted like this and so on. So for no matter how many times we repeat this, the pattern won't change now, because it is learned on Wikipedia text. So that is again another major difference, right? We don't know how Midjourney is training their byte pair encoding. Most likely they are using stable diffusion algorithm only under the hood, but how, their training data for training these prompts or image captions, a training clip, these might be, the training data might be entirely different and much more refined. So definitely the results we are getting here, and we might get on some public algorithms like stable diffusion, they can vary a lot. Here, as we can see, when we repeated it twice, wow, this is such a beautiful turtle, like amazing and mind blowing. Like again, blue shade, cute eyes, like oh god. And here you can see all of why this one is sad, I don't know. But again, you can see the text being reflected clearly across all the images. It shows like image journey, even though they have improved, they might have improved their uh, training data set, it's still somewhere down the line they contain such images where there is a lot of text present. That's how it is getting reflected. Again, when I repeated it 4 times, As you can see now, we are seeing again somewhat similar results. I don't know if it is by chance or due to frequency, because above also, no matter how many times we repeat it, we are getting very, very different kinds of results. And like I mentioned, some of the keywords here contain wide variety of uh, images, right? So in Midjourney dataset also, there might be wide variety of images associated with these keywords, and hence no matter how many times we run, we might see different or very unique results. Like you can see here, some consistency is still there, like monsters are there, big round eyes are there, either parrot or tortoise or turtle or frog. Certain beings are there, but there is some like owl is again here, some repetition of pattern is there, but still results are entirely different. Like here you can see a dragon again. Now this is like, I don't know if I think it tried to superimpose dragon and owl, because here I can see some feet like structure, and here you can see some teddy bear appearing, right? And again the texture, and this frog is holding a boat to something like that, and here a monster cake, a monster candy or something. So I think no matter how many times I repeat it, I might be getting very wide set of results. So still I'm going to go crazy here at it too many times, just to see if we get some different or distinct patterns. I'm gonna rerun these as well, just to see if there is any pattern emerging when we increase the frequency. So with increasing the frequency, we have only three keywords here, and all of them might be getting all of them are getting repeated thrice or four times, right? So model might be giving equal four times more weightage to each word. So in the sense, we might not be seeing uh, mm, results varying when we are increasing the frequency. Okay, we do something different actually, and when we are repeating it 8 times, oh, these are some beautiful results, and all of them are unique. All of them are. So here actually I see more again kid, as we saw baby and kid like faces. Again, this kid is holding some toy. This is playing piano. Again, like owl shaped monster with big round eyes, and here again we see a frog, but this time it is looks little old and wearing human like clothes. So again this time definitely there was some different uh, pattern emerging, but still not that unique. Actually here again we see kid holding some, I don't know, cup or something, and again you can see the helmet kind of thing she's wearing. And then, oh, this is skull. I don't know what it tried to generate. Skull, tick, skull. I don't know. Like these are something old TV set or something. Yeah, or washing machine. I don't know. But yeah, the results are like pattern is similar. I think I'll need to rerun these multiple times, because when I'm running 4 times, it actually is generating robots. Desert scene is appearing, I think, more often. Otherwise, no, actually, there is nothing clear here. But when I ran it 8 times, again, there is a teddy bear appearing, and wow, this is like has turtle-like body or something. And here we see kid bird, again beautiful, and this is some monster and some different artistic styles. So like I'll be concluding this video. I think if you are trying to get some ideas, to get some random images and see what it generates, definitely this keyword will give you some inspiration on what to try, what further to try, or what to create. Like clearly it gave me inspiration for a frog with such beautiful pattern, right? Like such beautifully colored, and there are these spikes coming out, and you can see these eye like pattern all over the body. So if you want to try these something more results, or see just want to get some inspiration, this is the keyword you can definitely try, and hopefully it might have given you more intuition into how these algorithms are working. So if you come up with some more crazy tip or trick, do share in the comments with me. So this is all for today. I'll definitely be coming up detailed video for those who are interested in knowing these algorithms. So I'll be sharing some videos on byte pair encoding, clip, and stable diffusion. So stay tuned for that. So that is all, guys. Thank you and happy new year.